All right, good morning from my end here. So today we'll be continuing with our class for month 2 of week 2, the second day. So for today, it's going to be exploratory data analysis with NumPy. So we learn how to explore data with NumPy, right? Remember, we've already talked about what NumPy is in the past class, in the last class rather, and we're able to digest fully what this NumPy is all about and how to create NumPy and so many other things that we spoke about. So, but in today's class, we're going to see introduction to exploratory data analysis, why use NumPy for exploratory data analysis, and then what are the key steps in what are the key steps in exploratory data analysis using NumPy, all right? So these are just the three components we're going to be looking at today. So let's quickly dive into this guy, Introduction to Exploratory Data Analysis with NumPy. First, we would like to know what exploratory data analysis is all about, right? So it is actually a crucial step in data science. So what it means is that you cannot complete your data science process without without doing your exploration or without doing your exploratory data analysis, right? So what that implies is that if you must do this, if you must carry out your data science projects, you should be able to understand what is required for your exploratory data analysis. It's a very critical step that if you don't handle it during your modelings, it might fail. There are a whole lot of things that could happen, right? And all of that. So, but with this now, you are able to do what? Understand your data set, right? And try to do things better. So it's a critical step in data science. It helps you to understand. The first thing is the structure of your data, right? So if you understand the structure of your data, or rather they say to understand the structure of your data, what is required is what? Exploratory data analysis. And then the second thing is the trends. The trends, right? Is with these trends that you'll be able to do what? Understand the integrity of your data. Because when you perform your bivariate analysis, trying to understand the relationship between one and two or more variable, right? You will now realize that, okay, probably it's because of this variable, that's why this other one is performing this way. So the trend is what will show you all of that. If this is increasing, does this reduce? So that is what it does. And also, it will help you understand what the characteristics of a data set. The characteristics of a data set. What are the characteristics of a data set? Are they linearly related? Is there anything like multi-collinearity? And then all of that will be also understood during the process of exploratory data analysis. So exploratory data analysis is actually commonly done with pandas, right? But then what NumPy comes in here to play for us is that the guy helps us during our numerical operations, right? So for instance, you want to establish a new variable, and then you can't use you can't use pandas to complete all of that. So, but NumPy will give you that aid to be able to do what to perform that numerical operations, and then um, it will also aid your your data manipulation processes. But then the both of them are not using independent of each other, but we can use them together, right? So how do we use them together? Probably when you want to do your numerical computation, you can bring in NumPy, and then your pandas is already when you have a data frame. When you want to even create a data or a series, or rather a data frame or a series, you realize you can make use of what's your NumPy, other than just calling forth your data from a file, right? So that is that. But why did we decide that we need to use NumPy for exploratory data analysis? The first thing is what? Its performance. Its performance. NumPy arrays are faster and consume less memory than list. So when you look at NumPy array, those guys they are what? They are faster, and it consume less it consume less memory, right? It consume less memory than list. So if you're going to make list, if you're going to use list in place of NumPy, you will notice that it will it will be lagging, and it will require more um and it will require what? More memory space for it to execute what? The task that is being given to it. So when you are considering how fast you can go, and how how fast you can be, and less memory. So what should come into your mind should be the use of what? NumPy, right? So the second reason why we use why we should use NumPy is it's vectorized operations. NumPy can allow operation on entire arrays without loop, right? So when we want to operate on a NumPy array, you can do all of that without any form of loop, right? But if um, you're making use of a list or any other data structure, you realize you will do what? You will need a loop for you to be able to do execute that. And then mathematical and statistical function. So we already stated in our last class that numerical Python, that's NumPy, has its own what? Its own how do they call it now? Its own ability to do or to perform mathematical operations. So it has some operators inherent itself, right? So that alone does some of the mathematical operations that for us. And then integration with other libraries. Integration with other libraries. It works seamlessly with pandas and matplotlib and scipy. So like we said already, it can work effectively with pandas, with okay, like we said, it can work effectively with pandas. It can work effectively with NumPy and as well as scipy, right? So all of this are what this guy can do for us. So let's look at our key steps in using matplotlib, NumPy rather, NumPy. So the first step is import the necessary libraries, which is import what's NumPy dot NumPy as NP. Import NumPy as what? NP. So if we run this code, you will see that NumPy has been imported. So how do you know your code has run? Is when it's showing your line and there's no error displayed underneath that particular line. All right. So creating the first step is what you will import necessary libraries. You import what's necessary libraries. So the second one is create or load data. Um, Creating or loading data. So we can, like I said previously, that we can create data. Most times it's synthetic data, and other times we can even create real-time data. No, sorry, real world, real case data rather. So that should be the right word. And then how do we do all of this? So we can do that, or we load the data from different files such as the CSV, the text file, or an Excel file. So the CSV file is known as a comma separated value file, and this is a text file, and this is an Excel file. So creating a NumPy array. So how do we do that? First thing is what data equals to np.array, open and close a bracket. Then your array is inside of it, right? This is your array. And then the print, the array is this guy. So we can run this. We will run this guy. Remember how to print your array. Just np dot array and then open a bracket. So this should be a one-dimensional array, just like we discussed in our previous class about the dimensions of our array. And then this is also creating creating our own array, right? And then we can also load data. We can create data here, save it to any of those files, and then call it forth again. So this is it now. Import NumPy as np. This has so this has already been done, and okay, so this has already been done. I mean this, right? So I have to be fast. I think my network is disturbing. So creating sample data. Let's create a sample data. I have numpy.array. This is also this should be a two-dimensional array. This is a two-dimensional array. So I have my first row, second row, third, and then to the last row. So how do we save the CSV? We have np.save text, open bracket, data.csv. So you have to do what? You have to call the extension name data.csv, right? And then what's the variable name? Data is a variable name here, data. And then what be the delimiter? What delimiter means is that what is the value? What is that particular feature that will separate each row from the other one, or that will separate each variable from the other variable? So we see here what helped us achieve this is comma, right? Because it's a comma separated value. So it's actually a comma separated value. I just hope this is going well because my network for my connection is shaking. All right. So we said the delimiter is what's comma. The reason why we're using a comma is because this guy we're saving it from the format of CSV, comma separated value. So what should be the header? The header is what ID feature 1, feature 2, and feature 3. So if you look very closely, this first column is carrying our ID 1, 2, 3, 4 to 10. And this guy is this, and this is this. So and then you can save. So for comments, you leave a space there for comment. So let's save the CSV file data.csv created has been created successfully. So let's load the file. Let's now load the file. Let's see how we can load the file. So we have data being equal to np.load text, right? So in loading the text, you call the text name. So this is data.csv. So mind you, that's what we wrote has come here, right? So it's now in our directory. So we can call this particular data. So why I want to explain this is that let's see the data. So see, here is the data. So why I want to explain this is that when we're calling this data and then we didn't specify the directory or the file path, that's because it's in the same directory as this notebook. So it will just check there and bring it forth. Then the delimiter is you also indicate the delimiter as being what a comma separated value size. So that means you have to use comma. So skip rows or equals to 1. And then we print, let's print the first 5 rows of this data. So printing the first 5 rows, we'll have what? This guy. So this skip row, what it does was that it removed the first row. So let's remove this to 0. What did I just do? Sorry. Let's do this and see what should appear. All right. So this guy should give us an error because what? It couldn't convert the string ID to float at row 0:1. So mind you, this guy, NumPy, only deals with numbers. So that's why you know what? It couldn't capture all of these guys up here, right? So is that. And then the next thing is understanding the characteristics of our data. So we need to know the shape and the size of that our data. So it's as simple as doing what data.shape. Remember how we did it last week? Sorry, last video. Data.size will just give you what you're looking for. So dot shape is telling you that it's 10 rows by 4 columns for the entire data. And then for numbers, number of elements, it will sum up the number, it will count the number of elements in our data set, and it's giving us what their frosty element. Then we can also check the data type. So data type would be what data.d type. Data.d type will tell us what data type this guy is. So this guy is actually a float. So if you notice very closely, when I was trying to remove the first when I was trying to ignore the removal of this first row, you realize that what the error was that it couldn't convert what those first rows that are actually strings into float, because what NumPy deals with numbers, either floating or integers, and as the case may be. So the next step, which is step 4, has to do what with handling of missing values. This is very, very important. Handling of missing values. So NumPy represents missing value with np.nan. So NumPy is actually the reason why most of our missing values are usually presented in form of what? NaN. That's not a value, because once it's not a value, once it's not a number, what your NumPy will see it as, it will see it as what? An NaN, right? Not a number. And then you can check and handle them using the first way we can do that is what detect. First of all, check for that missing data first. So how do we do that? NP dot is NaN. So you're just asking a question, is there a missing number in this data dot any? So in anywhere, is there a missing value? So are there missing values? And the reply is what? False. Remember, these are there missing values are just uh, how do we call it now? dummy, right? That is what I wrote to just describe what will be printed here. So the NP dot is any missing value in the data, right? And then if I stop here, it will print. Okay, let's take this guy and come up here and see what I'm explaining. So if you run this, it will be displaying false in all. But for you to get a wholesome response, you do what? Dot any. So if there is any, please display to me. So it will now go through and realize there's none. So it will now print out false for all of them. So if you look very closely, there's false, false, false for each and every one of them here. So then if there is anyone, you try to replace them with what? Mean or median, depending on your own perspective. So mean value will be what? np.na mean data, right? Then data will be equals to np. This is where you're declaring the mean, right? And then your this is where you're now replacing. So in that data, right? Please check np dot where. This is just like English language. So NumPy, please check where there is what? A NumPy missing value in that our data, right? What should you do? Please do what? Replace that with what? Our mean value in that data that we're talking about. So when we run this, nothing will be displayed because there is no missing value. So the step number 5, remember step 4 is what? Handling missing values. So step number 5 is descriptive data statistics. Descriptive statistics. NumPy provides various functions to summarize data set. So the first one is what? Measures of central tendency. So measures of central tendency, the mean, median, and mode. So how do we check mean? np.mean, np.median, np. By count or mode can give us that one. So let's run this guy and see what we'll get. So median equals to what? 14 point this. Mode mean equals to 41 point this. Median 39.8, right? So let's also check the measures of dispersion. Measures of dispersion. How are they spread? How is the spread of this our data? The first is what? Your standard deviation, and then you have your what? Your variance, and then you have your range. So if we run all of this, so we should be expecting that our deviation is 30.98. Our variance is what? 960.3240. And then we have a range of 97.7, right? So minimum and maximum value can also be checked. np.mean, np.max, and then all of that, right? So np.mean is 1.0, 98.7, np.max. So step 6 is for percentiles. So how do we check this percentile? np.percentile in data, then you specify this percentile you're looking for. So this percentile, I know you can look for any percentile, but the strategic points where we get our percentiles are usually 25 percentile, 50th percentile, and 75th percentile. So if you check all of this, you realize you're getting all of this. This is 11.5, 39.8, and then 67.7.5, right? So detecting outliers using z-factor, z-score. Outliers can be detected using the z-score method, right? So z-score equals to data minus np dot mean, open and close a bracket, data, right? Then slash np dot the standard deviation of that data. So once with z-factor is usually what? Z-factor is usually data minus the mean, all divided by the standard deviation of that data. So in a very simpler way, it's usually x minus mean of x over standard deviation of x. So for outliers then, outliers are usually what? Numbers that have absolute value of z factors which are greater than 3. So I chose a threshold of z score rather, not z factor, z score that is greater than 3, right? So let's run this and see. So there is no outlier. So all that means all of this data we created are within the jurisdiction of in line with there's no extreme value. So if you look, we have 78, we have 67. So it means the spread is kind of okay, right? So let's look at correlation and covariance. Finding for multi-dimension data sets, correlation and covariance help understand relationships between variables, right? So this is a sample where we have this first array. We'll have this array, and then we're trying to print the covariance. So how do we get the covariance matrix? It's numpy.covariance in this 2D array dot t. So this dot t is what? Uh, is a transpose, right? Because this is a 2 by 2. This is a two-dimensional array. So that's a transpose. And then np dot co co correlation coefficients, right? So we want to see the correlation coefficient. This is a covariance, and while this is the correlation coefficient. So if you run this, you realize that the covariance is what this and this and this. And then the correlation coefficient matrix is what 1 and this, then 0 point this and 1. So if you know your statistics very well, you should be able to understand what I have explained here. And then step 9 tells us of what data transformation normalization data transformation and normalization. So normalization ensures that the data is scaled appropriately for for comparison rather. So the first thing is maximum min max scaling. So in min max scaling, how do we perform min max scaling? So you look for what the data minus the minimum value of that data, all divided by maximum value of the data minus the minimum value of that data. So it's now normalize it for us. All of this is to help put the data in a particular scale, right? And then standardization is what? Data minus the mean of that data divided by what? The standard deviation of that data. Just like when you're looking for your z-score. So this is what this guy does for us. It will standardize it. So we have two form of data transformation and normalization, which is min max scaling. We have also the standardization. So in summary, NumPy provides lightweight, right? Lightweight, efficient way to perform EDA, especially when handling large and numerical data sets, while Pandas offers multi-function for tabular data. So NumPy excels in mathematical operation, transformation, and handling what multi-dimensional what efficiency. So for visualization, integrating NumPy with my matplotlib can help plot histograms, box plots, and scatter plots to further enhance what our data exploration. So to further enhance our data exploration, remember I already told us that there can be a collab between NumPy and pandas and matplotlib and also what your scipy. So all of these forms what is required for today's class. So thank you very much for staying around. See you in our next class.